So if you stick your thermometer into the ice and the water and you give it a good stir, the thermometer should read 32. If it does not read 32, then you do not have a calibrated thermometer. So if I can get this to 32, then I know when I stick it in the chicken and measure the chicken at 160, it's actually 160. Which is important because we want the chicken to be fully cooked. No.
Not 190 or 210.
Not 190 or 210. Now, something to know about big chunks of meat when you're roasting them, the center temperature is going to keep going up when we pull it out of the oven. So we might pull it out at 155 because the center temperature will continue to rise.
160, what? 160
Chicken? 160.
160.
I'm actually going to turn this way down. This one's going to cook the fastest at all. Okay. Well, hello everyone. As I was introduced, my name is Zachary Mazi. I am the executive chef for the Lionfish Supper Club, which is a new project that my friend and business partner Ty and I started in October. So we're actually pretty new at this. I've been catering and working in restaurants for about 10 years. I went to school in Portland, Oregon, although I knew how to cook before I went to school, and it took me a year and a half after school to remind myself that I already knew how to cook, because I was like, if I'm doing it wrong, what if I'm doing it wrong? I don't really think there's a wrong way of doing things, unless that's the last meal you're going to cook for yourself ever. You know, because you got to learn somehow, right? So just don't do it again. Maybe that's the wrong. If you do something that sucks, don't do it again. And change it up a little bit and do it different. So this is Lionfish Supper Club. We like to say good company and sexy food because we want to take it a little further. We feel like Santa Cruz is a little depressed in terms of our fine food selections. So we're kind of pushing it up a little bit. However, my previous incarnation was food as medicine. This is what I came down here as a therapeutic chef and really got into sort of healing with diet. I really believe that food and medicine are one and the same, and that we've really gotten distracted by this so-called healthcare industry, which is really sick care industry, isn't it? Like we're not making us any better, we're actually getting sicker. And so I think that food is our path to being healthier, and that learning how to eat and what to eat and how to recognize, especially recognize nutrient-dense foods, is going to be a really important step for us moving forward. Someone asked me what the #1 most important thing that we can probably do for our food and health is soil. We got to get our soil healthy, because that's where everything comes from, whether it's the feed that we're feeding the cows or the chickens or the pigs that we're eating, or if the plants that we're eating, or the medicines we're growing. If our soil isn't healthy, then our crops aren't going to be healthy and have the full gambit of everything that they need. And so I think that's probably, to get to the root of it, that's probably the most important thing. I'm just going to put this on really low heat. It's almost done already. Just got boiling a little bit. So I came up with this fun lecture to help you identify where you might find foods that are more akin to your body. I like to call it the fractal nature of nutrition, living on the edge. Is anyone familiar with fractals? Let's start in the back. What is nutrition? Anyone want to wait? What is nutrition?
Vitamins and minerals.
Nutrients? Vitamins and minerals? Anyone else?
Supplements that help feed your body.
Yeah. Does anyone else want to eat vitamins, minerals, and supplements for the rest of their lives? Yeah. Not me. So really, the nutrition is feeding the human body, right? Like getting us up to a place where our bodies are healthy. We are our own population. We are all we have, and our inner world equals our outer world. So what we put in is what we get out. Like very simply, input equals output. If you eat garbage, your body is going to break down, and you're going to become somebody who has to be taken care of for the last 20 years of their life. I don't think we're destined to do that. I think we've taken that as the norm, but I don't think that is the norm. If we eat healthy and I think happiness is part of our nutrition as well. Like nutrition is much more varied than just the nutrients, and that's the problem with science, is we compartmentalize everything and we break it down. So we do have nutrients, obviously. We have macronutrients, which are your proteins, your carbohydrates, and your fats, which now we're learning, even those can be tampered with. So fat does not equal fat, which is what I was taught growing up. Fat is fat. It has 9 calories. Better not eat too much of it. Well, now we know that fats like everything, have a wide variety of chemical forms, and those different forms, depending on even what's been done to them, can affect you differently. Like I was saying, polyunsaturates. You think those are a good thing, right? Because you've been led to believe that polyunsaturates are a good thing. Well, certain polyunsaturates are good things, but not all polyunsaturates are necessarily good. And none of them are good if they've been exposed to heat, light, or oxygen, because they're starting to break down. Micronutrients, that would be your minerals and your vitamins and all of the other things that we need. Then I came up with this idea of nano nutrients. I don't know if this is real or not, but your mitochondria need to eat. There's all kinds of little parts of your body that need to feed as well. And then there's a new study of quantum biology that's showing that not only are we interacting with the shape of the molecules, but it's actually the quantum charge across the surface of the molecules that our bodies are reacting to. And what that means is that our energetic history of the food equals the energetic future of the food. So another reason we need healthy soils and not to bomb it with poisons and antibiotics and all these things is because it remembers. There's a quantum memory that happens as food travels along the length of its pathway. So if you're traveling 3,000 miles from Indonesia where you've had really ridiculous situations and all of that is in the food. So there's a lot more benefit to eating local than just nutrient density. And by the way, when studied conventional foods versus organic, there wasn't much of a nutrient difference in organic versus conventional. However, there's far more pesticide residue in conventional. But the most nutrient-dense foods are the ones that were harvested most recently. So, and it dissipates over time. You pick a food, it starts to go down. So the more recently you can harvest, you can get your food, and the more nutrient-dense the soil was that it comes from, the more nutrient-dense that food is going to be. So I think nutrition is a moving definition, right? So we have a concept of how to properly nourish your body, and we are viewing this body in ever and ever greater detail, and it's always changing. You know, that's why it was polyunsaturates yesterday, and now it's omega-3 specifically, and then you got the antioxidants, but now it's like specific antioxidants, and like just getting bombarded with new things. It's all marketing, because all of those things are in healthy food. You don't have to worry about finding this particular nutrient or that particular nutrient if you're eating a wide variety of really healthy, locally grown foods. And that's the big takeaway. So what is the trajectory of where we're going with this? I'd like to change it. So let's step up. I want to introduce you to edge systems. Edge systems, this is a keyhole garden. It's actually a mandala garden. It's a circular pattern of nested keyhole beds. And this is something of permaculture. Is anyone familiar with permaculture or not familiar with permaculture? It's a gardening technique that you basically survey the land, and then you work with the land to use it in an energetic way that makes sense so that you're not fighting against the land, but you're actually utilizing what's already there. So if you have a stream, you build a dam, right? Because then you can store that energy. So the idea of the edges was from an observation. Saw that in the forest there's a certain diversity, in the field there's a certain diversity, but where the forest and the field meet at that edge, there is more life and more diversity than anywhere else. It's the same where the ocean meets the land. It's the same where your food meets your intestinal system. This is an edge system. There is more, it's also called turbulence in chaos theory. And there's life applications for this, as in permaculture design, and also what I'm going to share with you in nutrition. So the discovery was by a guy named Bill Mollison, and at the same time, simultaneously studying chaos theory, they started noticing they're studying the patterns of turbulence. Turbulence, incidentally, is an unpredictable direction of movement. So you have laminar flow and turbulent flow. Rapids, for example, in a river is turbulent. You might think the rapids, being the name, is moving faster than laminar flow. It's actually not, because if you throw a tennis ball in a river that's flowing smoothly, it goes, right? You throw a tennis ball in a rapid, it goes here, and it goes here, and it goes around. It may move more erratically, but it's not actually moving from point A to B to faster, right? That's turbulence. So they were simultaneously it's kind of one of those emergent things that was being discovered. Chaos theory is what came out of this. Chaos theory is the study of fractal geometry, and was originally started to predict the weather because it takes in an infinite number of variables and tries to show you how you can predict something that seems to be erratic, and now comes to, one of my friends was telling me you can use chaos theory to predict how heat from a heat lamp will travel across a room. In regular mathematics, it becomes very complicated. In chaos, it becomes rather simple. And from chaos theory, we get the idea of fractals. So what is a fractal? So a fractal is a simple pattern that repeats itself until it gets incredibly complex. So you can see you have a square divided into 9 squares. If you take each of those and divide those into 9, and so on and so forth, you end up with a very complex pattern. Same in here. So you have a line, you put a little box in it. Each of those lines, you put a little box in it. Each of those lines, you put a little box in it. And you get really complex patterns. You have your triangle, each face gets a triangle, each face gets a triangle, and pretty soon you have this incredible snowflake design. It's not a difficult or complex thing that you're doing, but what you end up with is something very complex. And this can become important. So you have the Amazon River basin, drainage basin. Very fractal, right? Now somehow there's water is draining from every single part of this into the main channel. That's pretty cool, right? This is a computer model of a simple branching formula. So you have this, it branches, each of those branches, each of those branches. This is what you end up with. This is an actual guinea pig brain cell. So the idea being that maybe what we consider complex in nature is actually a repetition of very small, non-complex things, right? But that becomes important because the thing on the whole actually has those complexities do have function. So what this is here, this is the part of something called the Mandelbrot set. This was one of the first fractals they discovered in their search for how to control the weather. Don't mind me as well. Make sure it stays good. And I'm fascinated with this. My uncle was a chaos mathematician. He gave me a book that this came out of when I was 8 years old, and ever since then I've just been blown away by fractals and really wanted to get further into them. So where do fractals exist? They exist on Earth, for sure. This is actually the Mississippi River drainage basin, or drainage area. As you can see, it's something like, well, it's very fractally. This is in Norway, I believe. This is near the fjord system. You can see it's river systems, fairly similar. This is in Nova Scotia. Now the challenge on this one is, can you tell me where the land and the water meet? Or you can tell me that this is definitely water. This is definitely land. But at some point, there's an edge there that you can't tell me where the land begins and where the water ends. And that would be the same if you zoomed in way into this and you could see where the water was lapping over individual sand grains, right? So the edges, like turbulence, are impossible to predict where one, it's just, and that's how fractals are generated. And that's as you keep defining the edge and refining the edge and refining the edge until you have nothing you can't really tell where one thing is the other. So I want to get into places that we find fractals in nature. So everyone knows what mushrooms are. Well, this is actually the fruit for the actual body of the mushroom. This is the body of the mushroom. The body of the mushroom is what's called mycelium, and it goes through everything where there's soil, there's been mycelium. And mycelium is responsible for the breakdown of soil all over this, of rock into soil all over the planet. And in an old-growth forest, 1 cubic inch of soil could have 8 miles of mycelium fibers. It's very complex, and there's good reason to believe that they're the first neural networks, and that our brains are mimicking a successful model that they had as far as transferring information. Plant patterns are fractals. Now, why do you think this is useful as a fractal? What does having a really frilled edge do for this thing?
It's water.
Access to water, right? So you have an edge now. Where does the plant and the air begin and end? And how much water can you pull out of that? Which is why redwood the pine needles tend to be flat, and they get a lot of fog, and they're collecting a lot of water. Same with this one; it's getting water. We are making fractals without even meaning to. We are creating centralized city units, and we have grid systems, and so we have fractals that are coming from the Earth. Anyone care to guess what this is? It's a computer model. The internet. Bingo. This is the internet on the planet. And if you actually connect it up to the satellites that are going around the Earth and all the connection between that, it gets even more crazy and complex. So I think they're looking for artificial intelligence in the wrong place. I think it's already here. I think it's been a part of the way that the matter of the universe organizes itself, and they're trying to recreate us as artificial intelligence, and they should really be looking into the next iteration, I think, which to me is a gigantic brain that already is here, right? So it's also in our body. Our bodies are kind of the ultimate fractal, right? So here's the blood system, here's the alveoli of the lungs, and here's what the blood system in the lungs. blue being going to the heart, red from the heart. So just how deep is this rabbit hole? Our brain structures are fractal, our nerve structures are fractal, our circulation system is a fractal, our bone density is actually fractals. We think of bones as being hard, they're actually porous and filled with a network. Our lymph system is a fractal, and think about it, because our immune system, our nerves, and our circulation system has to get to every single cell in our body, which is why if you barely prick yourself, you bleed. That means your blood is able to go to every single cell in your entire body. That's pretty amazing. There's a lot of cells in there. Our skin surface is a fractal. It may look like we have a definite edge, but if you were to look very closely, you'd have a hard time actually seeing where your skin began and where the world begins. And then our digestive system, which is what we're going to focus on today. This is a surface area maximizer. And there's a little something else that I added in that. So let's get into the digestive system. So your gut has 1/100th as many neurons as the brain. That may seem like a small amount, but it's actually ridiculously large, right? Just think of that, only 100 times less in your gut. So thinking with your gut instinct is actually probably a pretty accurate statement. We actually have more neurons there. It's called the enteric nervous system. It has a single vagus nerve that transfers all the signals to the brain. So when you have a gut feeling about something, or if you have, you get sick because of stage fright, these things are all connected, right? The way that our brains act and the way that our gut acts. The gut actually produces more serotonin than your brain. There was a recent UCLA study, and this is, I think, is really interesting. There's been quite a few studies since then that kind of show the same. But a UCLA study that indicates that the gut bacteria population affects brain function. So they had a bunch of women eat a placebo or Yoplait yogurt, which is the worst variety you can imagine, for a month. And they had them test their brain function, their depressive state, their happiness, their mood on various psychological tests. And the women who ate the yogurt for a month had significantly higher results on lower results on the higher results that they were looking for. So that was the UCLA was like, we've done it, we've proven it, having good healthy gut bacteria affects brain. Well, the GAPS diet, which stands for Gut and Psychology Syndrome, is specifically tunes gut health to overcome some very serious mental ailments such as MS and autism. I have a friend who actually got her son off of the short bus and off of medication by feeding him fermented foods. She's known as Kelly Deary. She makes creative culture beet kvass. She's phenomenal. She healed her husband of an autoimmune disease that was going to require surgery in a wheelchair for the rest of his life, and healed her son of autism, which is, I have a lot of opinions about where we've gotten ourselves into in this planet, and I think a lot of it has to do with lack of soil health, lack of gut biology, lack of proper health, and lack of diversity in our environment, and everything from the bacteria up to the food we eat. So the gut's really important, obviously. So the digestive system edges. Now, I like to say, just like mushrooms, we digest our food on the outside of our body. Don't you all? It's the hard one, right? We're actually a gigantic inner tube. If we ate our food directly into our cells, you can imagine kind of what a disaster that might be. Because, leaky gut, anyone familiar? What leaky gut syndrome? That means your food particles are actually getting out of your intestinal system into your body when they're not supposed to before they get broken down. So we actually digest on the outside. We have a tube that runs from our mouth to our anus, and we excrete digestive juices into that tube, and then we digest our foods, and then we suck the nutrients as it's broken down from that through the walls, and then are transported into the cells we eat. Whereas some, small organisms just envelop their food. We have to digest it, and mushrooms do that too. Actually, mushrooms excrete digestive juices and then grow into the broken down nutrients. So we're actually very much related to mushrooms. We're more closely related to mushrooms than we are to plants, believe it or not. So this is what's called a villi. It is covered with microvilli, and the microvilli are in turn covered with bacteria. What this does is it creates a lot of folds in our digestive system and allows us to maximize the surface. So there's multiple levels of surface area, and there's complex glands that excrete the necessary chemicals for digestion. And they're sensory glands, so they're responding to their environment as they're digesting. We have a probiotic population in the 100 trillions. And we only have 10 trillion cells in our body, which means that our bacteria in our body outnumber our cells 10 to 1. Now the small intestine, so this is the villi. We're going to zoom in on the surface. Now here is the surface of the villi. So now you have microvilli. So there's even smaller. So the small intestine has a surface area of more than 2 tennis courts if you were to spread it out. So you imagine the last meal you ate, turn it into a paste, and then spread it equally thin across the entire surface of 2 tennis courts. And that's how that's how much of a surface area your digestive system has. And that's just the actual cells itself, because we're then managed by gut bacteria, and some of these bacteria actually provide the energy for the epithelial cells. And in fact, our body this is where we can't really tell where our body begins and where the world begins. Because our body is not providing the energy for those cells in our gut, the bacteria themselves are. And I think there's a lot of research coming out right now about gut bacteria and its importance. And definitely pay attention to that, because there's some really cool stuff coming out right now. So the cecum is this area here. This is where the small intestine comes into the large intestine. It's the gateway to the large intestine, and it's the storehouse for the bacteria in our gut. Most of the bacteria in our gut are in here. Anyone know what this little thing is here on the side? Fingers thing? That's the appendix. Totally useless, that's why it's wrinkled up. The human feces, when we're pooping, can actually be up to 30% bacteria. So we're producing a lot of bacteria in our gut, and they're helping us in our large intestine. Mostly, they're feeding themselves and breaking down fibers and helping us extract the water from the food. The appendix, which is this tiny little thing here, vermiform process, the worm process. It was considered a vestigial organ because it's so tiny, and what could it possibly do? Well, it turns out that it's the safe house for helpful bacteria, which are the endogenous probiotics that live in your system, which means when you get violently ill from food poisoning or sickness, and you are ejecting everything from your body out of both ends and sweating everything out, your appendix seals up and keeps a library of all the things that need to be in your intestine. And when you are recovering, it opens up and all the bacteria come out and multiply and repopulate your gut with what it needs. So when you bombard a body or a series of bodies or a whole society with antibiotics, what you end up doing is clearing the appendix out. Now you have the Heartbreak Hotel that's waiting for anything and anything to come in. You have a series of appendectomies because now this useless organ that does nothing is empty and is filling up with bad bacteria, getting infected and getting inflamed, bursting, at which point you're now putting food into your body, not on the outside of your body. That's a serious problem. So I think we've seen a decrease in appendectomies as we've seen a decrease in the antibiotic use. So that's good, but it's a pretty useful little thing. So there you have it. 100 trillion organisms. We have viruses, which are sort of our immune library. We have fungus, which we really don't know much about the fungus in our bodies. We have up to 1,000 varieties of bacteria, which is 10 times the number of human cells, but within that, 150 times the number of genes that we have. So there's 150 times more genes in our gut bacteria than there are in our DNA. So there's a lot of information, and they're trying to decode the genotypes of all these bacteria in our guts because we don't even know what's in there, and it's way more complex than we are, which is kind of fascinating. So the edge systems, again, the edges are where it's happening, right? And then we got mitochondria, which potentially many millions of years ago, billions of years ago, millions, a bacteria or a small organism ate another one and was like, whoa, this is spicy, this has got a lot of energy, I'm not going to digest this. And it took in the mitochondria, and now the mitochondria live in all of our cells and provide the energy. But at one point, it's postulated that they were a separate organism. So even within our cells, we've already adapted to having an edge and having more creatures inside them, right? I think that's really fascinating. This is actually a photoplate of an electron microscope of the inside of the gut. So you've got bacteria, you've got viruses. This is a fiber.
The log?
The log is a fiber. Pretty cool, huh? So I want to talk a little bit about the edgy sources of life and where we can find good nutrition in food, and and my theory is that the foods that mimic the way that our guts are, which is have this extreme edge, and the foods that grow and sort of have those same qualities are the foods that tend to be the most nutrient dense. And I think what you'll find is when you pick a food and it's fresh, which is now shown to have the most nutrient density, it's got the most edgy thing going on, right? It's still almost exchanging at its surface. You pick a fresh lettuce leaf right out of the garden, there's still water exchange happening, there's still bacteria on the surface, there's still things going on. You know, if you go to Safeway and you pick some 7-day-old sort of thing and you try to ferment it in your natural fermentation, who knows what you're going to get, because God knows where that thing's been or what kind of bacteria is on there. But if you go in your garden and you pick like nice, fresh cucumbers and you shove them into a salt brine, you're going to get the most delicious pickles you've ever had, because there's a healthy bacteria population on everything, and that's what creates the natural ferments and the probiotics that you're looking for. So you can take your supplements, you can take your probiotics, you can drink your kombucha, which this one's a really good one, by the way. Like no sugar from these guys. Or you can grow your own, and you can rely on having your own kitchen, which I actually think, given the energetic history, it's really useful to grow your own probiotics, make your own pickles, make your own sauerkraut, because then you're kind of interacting with it. And I think there's a lot to be said about energy and the way and what we put into our food.
Are you going to talk about cooked versus raw? Because doesn't the cooking process kill the bacteria?
Yeah, the cooking process does kill bacteria. But it doesn't necessarily kill all the beneficial things that the bacteria bring, because the bacteria are producing not side effects, what am I looking for? Bacteria are producing basically compounded chemicals that are also beneficial to us. So it's not only that the probiotics are good, it's also that they produce things that our bodies come to rely on. So cooking doesn't necessarily destroy everything probiotic, but yeah, you definitely want to eat them more raw. We kind of skipped on that one. I'm hoping that under the skin the miso doesn't get too hot, but probably we're going to kill most of the miso and bake in the chicken. It's going to taste really good. So I want to talk about seaweeds. Talk about an edgy plant, right? This is you can see this if you go down to the Monterey Bay Aquarium. They have some amazing kelp gardens down there. So seaweeds grow on the edge. Remember that edge that we looked at between the ocean? Now imagine that those edges are now even more edgy, because they got seaweeds and mussels and filter feeders and all these other things growing on them, which are all edge systems. They're kind of like the lining of our digestive system where the ocean meets the land, right? So seaweeds, there's about 400 species. It's the most complex algae on the planet. It's not actually a plant. Has no true stem, leaves, or roots. They're extremely nutrient dense. They are mineral dense, and they're the most rapidly growing food source on the planet. That's really useful. Some algae can grow 2 feet a day, and they're extremely nutrient dense. So if we want to sustain ourselves, growing corn is probably not the best way to do it when we can grow things that grow incredibly quickly. Now, saltwater life begets interesting constituents, because salt tends to pull things out of cells, right? So when you get wrinkly in salt water, or you reverse, or basically it's through osmosis, right? If you put something in salt water, the content on the other side of a semi-permeable membrane wants to match the salt content here. So if this is high salt and this is low salt, the water from the low salt is going to flow out of that and cause this to shrivel up. So this is why salt kills slugs. You put salt in a slug, it pulls the liquid out of the slug and literally like sucks it out, because slugs are made of a lot of water. So things that live in salt water have to compensate by filling their cells with salty aminos, complex chemicals, and all kinds of other things to make a balance of the dissolved particles, so that when they're in the salt water, it doesn't pull them out. This is why fish are so delicious just by themselves, because they're filled with aminos and salts and other awesome chemicals called inomino-phosphates and various neat things that are just part of living in salt water. Same thing with seaweeds. So seaweeds are definitely have tons of iodine, magnesium, iron, B6, calcium, and selenium. All seaweeds have these, including, basically seaweeds have whatever minerals are in the ocean, which is good and bad. So if you have Fukushima radiation and mercury, you can find that in your seaweeds. Now, we can't assume the oceans are ubiquitously poisoned by these things, and probably the radiation from Fukushima is far less than some of the extremists would have us believe, and far worse than the government is telling us. Somewhere in between, I'd say for now your California seaweeds are probably still pretty good, especially the North Coast. Nori has a very high omega-3 content, which our body needs. They have the highest source of non-animal B12, which is in wakame. Anyone in here vegetarian? How long have you been vegetarian?
A couple decades.
Oh, you?
About 20 years.
A year.
A year? So it's really important. Vegetarians less than vegans, but it's really important when you become a vegetarian to make sure you keep up on your B12, because your body actually stops absorbing it if it doesn't get exposed to it. There are a couple great naturopathic clinics here in town that give B12 shots. I prefer the Fridays at Thrive Natural Medicine. The doctors there are great. And you can get B12 directly in your bloodstream, so if you're worried about it. And it always feels good anyway, they're only like $15, so I recommend that. But it's really important to always maintain your B12. So seaweeds are great if you're thinking about becoming vegetarian or vegan. Make sure that you find your non-animal sources of B12 and get those. And if you haven't kept up on that, and you want to just go get some B12 shots, because sometimes the supplements don't even get digested anymore, or your body just can't assimilate it anymore. There's high protein content by dry weight in nori, has the highest. All of them have fiber for digestion and also tend to fill you up more. That's one of the useful things about fiber, is it makes you feel full faster, so you tend to not overeat. And all of them have a specialized balance of aminos, which is a product of the saltwater issue. So living foods. I like to think of living foods as edgy foods as well, mainly because they're in a process of eating their way through whatever medium they're in. So you have yogurt and kefir, cheeses, miso, tamari, tempeh, that's your soy, your beer, wine, and sake, that's a yeast food, although sake has both a bacterial and a yeast culture. Sauerkraut, naturally pickled foods, those are your lactoferments. This book is amazing. I highly recommend getting this book on your shelf and reading it. It is so accessible, and it's sort of one of those books of like, forget what they've told you, just do it, it's easy. Which I love those books. And yeah, I learned from that you can actually ferment your oatmeal before you cook it if you eat oatmeal in the morning. You can let it sit in water for 36 to 48 hours and it becomes almost like a sourdough oatmeal. And then you can eat that and it becomes more creamy and more digestible. So part of the probiotics is it's got a lot of nutrients and it's got our probiotics. Part of it is it breaks down our food for us. So it's pre-digested, and part of it is that they produce a lot of side products and byproducts that are also very good for us as they're breaking down through things. So I like to think of them as edgy foods because it's more like the edge of our gut, or the edge that's our DNA. It's sort of the infolding edge, right? It's not necessarily a defined edge. But again, these things are so important to our health because they mimic what's going on in our gut. So the seaweeds, I think, are kind of mimicking Alveoli, right? It's very edgy. They're absorbing a lot of things. They're filtering, and they're bringing a lot of nutrients of the ocean into a concentrated place. Just like our gut is bringing the chyme, the concentration of nutrients of the chyme into our body. Same thing with the living foods. We're introducing to something that was sort of static and unchanging, a living food, or a living creature, or a living organism, which is then going through and changing that for us. So that's why I think living foods are edgy. So the benefits of living foods, well, the bacterial cultures, fermented foods that replenish our gut bacterial cultures. Having a healthy population has been shown to prevent yeast infections, urinary tract infections, obesity, and aids in good digestion. In fact, they did a fecal transplant study on obese mice, and they had bred mice to not have a certain bacterial population, and they got very fat, and they did a fecal transplant, and those mice lost weight when they put the proper bacteria in there, when the bacteria could actually break down the foods for them. We didn't have refrigeration for a long time. When just like with our appendix, if you have the right population of bacteria in there, then you can't get the bad bacteria in there because they outcompete them. So this has been used for preservation. So we've relied on fermentation, both salt fermentation and bacterial fermentation for preservation for many, 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 many thousands of years. And they have really good nutrition. Most of the foods are low in sugar. They're high in fiber. The vitamins A, B, C, and E are often created as byproducts. They can stabilize your blood sugar, so they can cut your cravings. Having a healthy bacteria also helps with the weight loss and helps brain function, or at least bad bacteria disrupt brain function. That's something that we know. So there's a lot of benefits to having living foods in your diet. And my favorite topic, fungus. We touched on this a little bit. So I see fungus as an edgy food, one, because of the way the mycelium works, it's like the ultimate edge, but also it's the edge of seasons, right? This is when the rains come, and they knock all the organic matter down from the trees and whatnot, and now the fungus come out to start digesting and moving through and breaking down into soil and changing it and enriching it and bringing in, actually sequestering carbon, which is really useful. If there's a really, really powerful talk out there right now, an elegant solution to saving the bees, I highly recommend it. It's 23 minutes long or something, and your mind will be blown, I promise you. It goes into the details of what mushrooms have actually been doing in our ecosystem and how blind we have been to the importance of the mushrooms in our environment. So mushrooms are seasonal. They have cyclic patterns of growth, and they emerge to reproduce when food is plenty. They're very mysterious medicines. These things are ancient. They're older than plants. They're older than us. They seem to instruct our immune system on how to work more efficiently. They are intelligent.
Oh, come on.
They do. It's weird. They actually they stimulate the immune system when it's needed. They do not stimulate the immune system when it's not needed. So if you have an overactive immune system, mushrooms will prevent it from being overactive. If you have an underactive immune system, they will stimulate your immune system to work better. Turkey tail mushrooms have a decloaking device for tumors. They can actually, it's like they go to the body and be like, it's over here, it's right there. And the problem is it's not getting much funding because there's no direct action, and the FDA wants direct action. They want to say, this thing and this thing does this thing, and that's why we can patent it. But there isn't really, they don't do that. They're kind of like, hey, look over here. They're like, hey, do this. And they help stimulate your body to produce more things that you need. So they increase your natural killer cell, and they increase the effectiveness of natural killer cells. And mushrooms are intelligent both in nature, in our bodies, in the way they work, and in labs. So they have been shown that they sense when you're present. There's certain tree funguses that excrete different chemicals in the presence of people. So they set up a little thing on the conch. As people approached, it actually sent out signal chemicals, almost like it was looking for and responding to the presence of creatures. They are present, they're intelligent in the laboratory. They took a slime mold, they put it in a maze. Slime mold grew out through the entire maze, found the exit with the little oat that it was looking for. They took the slime mold out of the maze, they put the slime mold back in the same maze, and went directly to the exit. Didn't have to explore the second time, it knew where it was going. These things have a memory. A group of engineers used the same kind of slime mold to redesign the subway in Tokyo. So they took a map of Japan, or a map of Tokyo, and put all little straw or little oat pieces where all the main cities and hubs would be. They put the slime mold right in the center, and they said go. Thing grew out, found the oats, and found its thing, cut off all the non-necessary paths, and found when they ran the simulations it was like 40% more efficient than the train system that they built. So these things are really intelligent. There's an intelligence in nature that we are letting go of here.
So is any of this lost when you cook the mushroom?
No, it's not, interestingly enough. In fact, you can actually access it when you cook the mushroom because we don't produce chitinase in our guts. Mammals do not produce chitinase, and mushroom cell walls are made of chitin. And so we can't actually break down the cell walls of raw mushroom. So you have to cook them to get your medicine.
Is that chitin?
Chitin, yeah.
But I was wondering if by that insects.
Yes, chitin, yeah.
Yeah.
So arthropods have it as well, exactly.
So they're magical like the psilocybin mushrooms then?
Sure. Psilocybin mushrooms have been shown, there's been more research coming out on a lot of use in brain function. And there's a group here in Santa Cruz called MAPS, Multidisciplinary Approach to Psychedelic Studies. And they've been doing research on using mushrooms to help people in hospice who can't let go, are too afraid to die, and are struggling and having a really hard time. And they're doing mitigated psychological mushroom trips and showing them that the world is much bigger and much more gentle, and it's helping people actually able to let go. So there's a lot of, I don't think that, we have a lot of bias as to what is medicine and what isn't medicine. And I think that we have to reopen our whole examination of what is going on out there. And then beyond that, mushrooms are nutrient dense. They mitigate the transfer of nutrients throughout the entire forest, so they can take nutrients from the oak tree and give it to the fir tree and vice versa. They're full of life-giving properties. They know how to mine rocks. They create soil. They break down toxins. They demolecularize any kind of petrochemicals. They actually can take an oil spill and turn it into mushroom sugars. There's a lot of, I have this little cynical joke that, once humans kind of wipe ourselves out off the planet, the mushrooms will be like, okay, let's go. In 10 years, the planet will be back to normal because we'll just eat all the plastics and we'll just take care of it. So fungal reproduction is pretty cool. They're surface area maximizers as well. They have these little things called basidia on their gills. And the basidia produce these little spores. This is sort of a microscope picture of it. So kind of like our villi. The basidia produce 2 or 4 spores. The Ganoderma, which is the tree conch or the artist conch, you've seen a bunch of them, can produce up to over 1 trillion spores in just a few weeks. And the giant puffball can contain about 7 trillion spores. And if each of those grew into a full-size mushroom, the total mass would be 800 times the weight of Earth. So these things are very efficient in their edge systems and edge producers. So I think they mimic our gut a little bit, and they mimic the way that our bacteria are in our gut. So I think they're really important. Mushroom nutrition. All mushrooms are anti-tumor to some degree, a little bit or one degree or another. And they're extremely nutrient dense. You find A, B complex, C, D, E, K, CoQ10. There are proteins. And some mushrooms like porcinis have all 8 essential amino acids, and when dried are 80% protein by dry weight. So porcinis are actually a really good source of non-animal proteins. They tend to concentrate minerals like selenium, zinc, copper, iron, gold even, potassium, sodium. They produce a bunch of different weird compounds of steroids and phenols and all kinds of strange things. Over 250,000 unique compounds have been isolated in the reishi mushroom. That's just that the reishi mushroom produces. There's a whole chemical factory in there. They have all kinds of crazy exclusive chemicals, and often they're named for the mushroom. So the shiitake, which is called lentinula, will have lent to this and lent to that, and it's like all named after the mushroom, and they're things that only exist in that mushroom. And this maybe is why they're intelligent and why we can't figure them out. They're antimicrobial, antiviral, antifungal. They're probiotic supportive. Shiitake mushrooms will simultaneously kill staphylococcus in your gut while providing mushroom sugars and helping your bacillus at the same time. So they aren't necessarily, they're intelligent. They're not just like the antibiotics we have, which are just like a wrecking ball that just comes in and kills everything. They actually selectively kill the bad things and help the good things. And one way or another, there's mushrooms that support all of the body systems. So I kind of wanted to see how deep this edgy rabbit hole goes, because we've been talking about nutrition and guts, right? So we got a brain structure, we looked at all this, but there's another one. Let's look at our DNA. Talk about the ultimate edge, right? So DNA and epigenetics, this is something I added fairly recently. Is anyone familiar with the term epigenetics? It's starting to gain popularity. Basically means what happens afterward. But so how edgy can we get, right? So we have DNA, we have this little coiling thing. Well, it twists up, and then it twists up around these histones, and then these histones twist up around another thing, and then this thing balls up and twists into a chromosome, and then those chromosomes are packed into our cells. So there's approximately 6 feet of DNA inside of every cell that has DNA. That's a lot. So how do you pack it all in? Well, we twist it, and we pack it, and we pack it, and we twist it. And when the cell divides, it can, what it's doing is reading the DNA to manufacture certain proteins. And it doesn't necessarily unwrap the entire DNA structure at one time, it unwraps certain parts of the DNA. And the body, through various chemical processes, tells it which proteins it needs, so it unwraps that part of the DNA and reproduces that protein. Well, it does that through a process called methylation. Methylation is attached as a methyl group, which is this little Me onto the DNA, and that is sort of the copy me or don't copy me. It's the on or off switch. Methylation happens about 1 billion times a second in your body. It's all the time it's happening. And it can be affected by our environment. So car exhaust can trigger a certain type of methylation, whereas good nutrition can trigger a different kind of methylation. So I believe that as people exercise and get more healthy and introduce more healthy foods, you can actually see them physically change. It's not just, they don't just become thinner, they actually physically look different. They actually are starting to glow from the inside out. That is because the DNA is being made more efficient and is actually doing what it's supposed to do, because our bodies are designed to be in perfect health. We are meant to be at our best state. And if we give ourselves everything we need, such as we had before our agriculture and industrial revolutions, that we were probably extremely healthy, and we didn't need to write down our history. We had 250,000 years of of human sort of populations being healthy and eating what we were supposed to eat with extreme nutrient density, right? So I added this cell yesterday. I thought this was really cool. This is the DNA packing. So you've got here's your, the 4 code letters of your DNA, and they match up in certain ways. And they unzip to form different proteins. So they wrap, and they become your double helix, which we've become familiar with. And that double helix wraps around these things. These are called the histones. And these histones hold a little curl, and then the histones pack around yet another thing. So these are each one of these is a histone. And then those curl up, and then that curls up inside of the cell. So there's a lot of curling, and a lot of curling, and a lot of curling, and a lot of wrapping up inside of your cell. I mean, 6 feet for a single cell is a lot. So not every gene is expressed in every cell, despite having identical DNA, right? So maybe the DNA isn't actually all we need to learn about, because the epigenetics instructs the cells how to become individualized from certain parts of that DNA. So there's a huge process going on that's outside of our DNA that's fascinating. There's a really cool animation if you want to see real-time DNA replication. I highly recommend checking this out. There was a TED Talk where this guy shows it, and it's crazy how fast these things go. And the animation's there, and it's like proteins are like amino acids are just floating out of the cell and like being attached as it's assembling this protein. It's like, where the hell did those come from? Like who? It's like, do they have this little arm? Like, it's so weird. It's like, if you really think about how your DNA can actually function and how quickly it replicates, it's replicating itself at a speed of like that fast. That's how fast the base pairs are just constantly doing this in your cell. So epigenetics is the study of what happens on top of DNA that we've become so familiar with. Stress, environment, nutrition can all affect your epigenetic expression. It can have long-term health effects if ignored, even generational health effects. I think this is evidenced and spoken to by the way that nature has separated what's called the gonatogenesis of females and males. Gonatogenesis is...
Crystal for a third, please. Crystal for a third, thank you.
Gonatogenesis is the time in the human body when the gonadotropes are being formed. So in women, all the eggs that you are carrying were formed when you 120 days before you were born, right? So whatever was going on with your mother at that time has epigenetically affected the DNA of what you are going to pass on to your children. Now with men, it's the 74 days before that sperm is produced, which means that in, say, large populations, if you have a drought, it's probably only going to affect one of those, right? Because you have about a 20-year spread between the reproductive times. So when the gonadotropes of the men and the gonadotropes of the women meet, there's about a 20-year gap when those things were made. So hopefully, what I think is that's nature's way of saying, okay, if there's bad nutrition during this decade, that at least half of the DNA will be in good nutrition one way or another. And I think that is evidence that that's how important epigenetics is, that we really overlook that. So genes that can affect obesity, mental health, and autism, and so much more can be turned on and off. So I think we all have these genes. And yet as we increase our toxic load, as we increase the car exhaust, we decrease our nutrients from our foods, we increase antibiotics, we increase pesticide residue, the people that have a more propensity to have those things pushed over the edge do. Which is why, there's a lot of apologists that say, oh, well, we're just getting better at diagnosing autism. That's why there's more autism cases now. That's like the denier. It's like, come on, look around. There's something going on. And it's probably because we have pushed it too darn far. I'm going to take a temperature of these guys. It's good to get it right down in there by the bone of the leg. Might take it in a few different places on both of the birds too. So those are about 120 right now according to this thermometer. They also are finding that stress can affect epigenetics. For example, they discovered that kids that are born with C-section before the actual labor begins, so this is let's just take care of it and get her done, that the nature is extremely efficient. So everything that happens, nature utilizes, right? Because it can't waste anything. Well, it turns out that the baby being squished through the birth canal, or even the labor contractions before being squished through the birth canal, can trigger a stress response cycle that is then used later during stress response in the world. So if you were born by C-section before any of that stress happened, you have a lower methylation and a less likely chance of being able to deal with stresses as they occur in your adult life, which is really fascinating. So here we are trying to make things more efficient, and we don't realize how efficient nature is, that even the stresses that we're put under are utilized to jumpstart certain parts of our immune system and of our ability to deal with things. So the magical deoxyribonucleic acid. So if 60 to 80 billion cells die daily in the adult human body, and there are 6 feet of DNA in every single one of those cells, and the adult human body is in a state of not getting any heavier or any lighter, right? Because we stay fairly the same size for many, many decades. That means that 60 to 80 billion cells are being made in your body every single day, which means that 6 feet of DNA is being reproduced in every single one of those cells in your body every single day, which means how many miles of DNA is your body producing daily? Somebody's going to be smart ass and tell me billions, and then it makes the numbers. It's anywhere from 60 to 90 million miles of DNA every single day in your body is being reproduced. 60 to 90 million miles. That's the distance from the Earth to the Sun. Every single day, flawlessly, with hardly any errors. Whoa. So if a hypothetical photon began to traverse the length of your DNA in every single one of your cells, moving at the speed of light, it would take it 26 days to travel the length of your DNA. 26 days. Which means that 14 humans' DNA laid end to end is a light year. So we are already traveling the galaxy, right? We are incredibly complex and wound up. And this is copied, tampered with in real time at breakneck speeds all the time as long as you're alive. And I talk about the ultimate twisting fractal of creation, right? This is, imagine what it would look like if you could see someone just the DNA that's replicated in their body right now and take away everything else. If anyone smokes DMT or tried ayahuasca, that might be what you're seeing. Who knows? So this guy was a cool image. This is our fractal guy. So what is fractal nutrition? So I like to say that Western medicine and our Western practices blunt the edges, right? So we're looking for unblunted, edgy health that mimics the natural order of the universe, of our world, and our bodies. So the Western diet's not aware of this yet. And they blunt the edges aggressively in antibiotics, in all sorts of ways, and results in multiple diseases that are killing thousands yearly. Thought I had another slide in there. So like homogenization, pasteurization, monocropping, these are all ways that we destroy edge systems. We're destroying them constantly in our Western ideology, and we don't really realize how important the edge systems are. Because on a cosmic scale, it's all the same. So you have bone density, brain cells, dark matter in the universe, all kind of looks the same on all levels, because the edge system and the strings and the networks are the way that we form. And so by identifying the foods in nature that mimic that, you're going to be sure you're going to find the foods that are better for your body. And so it's really, for me, the importance is really understanding how to identify those things. So, you know, the universe is a fractal, we are a fractal, and we're constantly in flux, and we mirror our surroundings. Our DNA is responding. If it's reproducing that many, 90 million miles every single day, 60 million miles every single day, whatever it's bathed with as it's reproducing, that's how the methylation cycle is reading. So we need a nutrition that's based on the movement and flexibility, and foods that mirror the complex dance are again and again have been found to have the most densest of nutrient profiles. So let's have a little argument against factory foods. Homogenation destroys both the fractal qualities of foods and their individual makeup. Pasteurization destroys the fine networks of protein, the living foods, and disrupts the natural order of the complex dance of life. If you take raw milk and pasteurized milk and set it on the counter and let it sit there, that raw milk is going to turn into something that's more akin to yogurt. That pasteurized milk is going to be stinky and nasty and disgusting, because just like the appendix, you've gotten rid of the natural occurring bacteria that are in it, and now it's allowed for anything to get in, and it starts rotting. Monocropping eliminates the varieties of natural foods. For example, we've gone from 500 varieties of potatoes to us here on the West Coast being able to name maybe 3 to 5 kinds. Most people think of a potato as a potato, right? Hence the Irish potato famine, because they used one potato and a blight wiped out the entire thing, because that's the only thing they monocropped it. And antibiotics in foods allows for the misuse of feed, misuse of medicines, and destroys the living systems that exist naturally, both in the soil and in our crops and in our livestock. So pretty good arguments against factory foods using this theory. So this is just a cool graph. This is a comparison between primitive and modern man's intake of some vitamins, minerals, and fiber. The yellow is standardized, so that's our USDA recommended daily amount. This is how much you should have. If the primitive man, the blue is if primitive man ate the same amount of calories that we ate with the foods that they had, this is how much more of each of these things they would have. So you got folate, vitamin A, carotene, calcium, thiamine, zinc, riboflavin, vitamin E, C, fiber, and iron. However, primitive man ate way more calories than we eat. And so the green bar are actually what primitive man's nutrient intake is compared to ours, with our standard USDA. We're talking significantly more, 800% more iron, right? 700% more fiber. Like this is like significantly more nutrients and far more nutrient dense. So this idea that, well, they only lived to 30 years. Life expectancy average was 30 years because there are saber-toothed tigers and there are various things, but there are still people that live to 80 and 90 in those days. So don't think just because they say the average was only to that long. I think that there's probably a lot more, there's a lot more going on in our past than we tend to give credit for. So we need a new definition for nutrition, and I think that has to be flexible, has to be individualized, because we all have different starting points. We've all been exposed to different chemicals and different antibiotics. It has to be open to change, because we're learning new things all the time. It needs to be artisan, because artisan is got the energy of creativity, and also tends to be more localized and tends to utilize what's around us. It needs to be ancient, because there's a wisdom that we've forgotten that kept us alive and kept us going for a long time. We've tried to kind of jerry-rig that for a little while now, and it's not working. It needs to be alive. We need a living nutrition. We can't be eating supplements and vitamins and no, I recommend B12 shots. Getting it from nature is going to be a lot better for you because it comes with a whole suite, a whole delivery system. It needs to be local because, for example, local honeys are going to have the pollens that you're reacting to from your allergies, just like local mushrooms are going to have the antibiotic properties for the local bacteria. And it needs to be wild because there's a wildness to the edges that we can't replicate. So that's the end of that. Any questions?
So for all your lab work about mushrooms and fungus, how do you explain the ones that want to kill us?
They're not poisonous, they're just highly concentrated. There are some really cool studies with death cap mushrooms using homeopathic doses and they are curing cancer at 10,000 times dilution. So I think that it's not poisonous mushrooms, it's just that they're very highly concentrated with I don't think they want to kill us necessarily, they just don't want to be eaten. So if I may, I have another voice that I like to use sometimes. I do poetry, and actually right now I am not at poetry because Monday nights at the Tannery is the best poetry night you could ever go to. And I'd like to give a poem to you guys. That's all right. Alternative. Of or relating to behavior that is considered unconventional and often seen as a challenge to the traditional norms. Traditional. Adjective. Of or belonging to a tradition, long established. What is the norm? Culturally conditioned individual. Traditional, yet somehow I've been convinced that I'm not the aboriginal, even though the original blood still flows through my leaky capillaries. Thanks to Dr. Leaky, you can trace my genetics back to the Olduvai Gorge, back to the original Eve. Lucy loosely traced this mitochondrial DNA, and somehow you've convinced me that I'm not indigenous. What is the source of this insidious train of thought? I exist. My body's existence is a resistance to these chains of thought. I exist without these definitions. I have been around for eternity, earning these burning words, and somehow it's I that's labeled as alternative. I expand my thoughts to entertain the possibility that people just like me have walked this earth for at least 10,000 generations, thousands of migrations, civilizations, each tracing their origin to the original tree of sin and sinew. No telling the trials we've been through. Each man, woman, children, each man, woman, and human, children too, each carrying the same burdens as you and I, just as urgent in their puny lives, just as certain as our unbroken line is traced intrinsically to the original plant and mushroom medicines, as foods and evidence, suggesting we have been sentient, Homo sapiens sapiens pregnant with the ancient pregnant with the future since the ancient, different only in the color of our skin or the length of our hair, whether we have breasts or not, whether we choose to beat chests or talk, how we choose to express our grief and ingest our loss. Because truly, what is the cost of our amnesia? Because we have forgotten who here is actually alternative. As Bayer and Pfizer alter the natives, our cultures are shaken. I'm standing at this altar and waiting for some sobriety to pierce this insanity, because we've gone from hunter-gatherers to farms to pharmaceutical companies that hunt and gather our information from data farms, fields apart from the plains we once roamed, gathering statistics to manufacture everything from lipstick to ballistic chemotherapy that kills the host just as well as it kills the cancer. Touting their disharmonized health norms is the only answer. So I practice alternative medicine, healing with natural methods and breath work, traditional culture that's been around for 2 million years or more. Listen, if our fire-using ancestors have been on this earth for just 24 hours, it's just the last 13 second-hand ticks that our oceans have become, excuse me, get choked up with this word. Our oceans have become radiation and plastic. Our rain's acid, our food a tragic story, secondhand, used and flaccid. And you ask me why I have to master this diction to speak truth to power, causing heat and friction in this final hour. You have left me no alternative. Now that the rice and the vegetables are done, there are some plates here. You can come and get some food. The chicken should be out of the oven shortly. I appreciate you guys being here.
Yeah. Oh my gosh. Wow. Yeah, a lot more than I bargained for.